Hi everyone, and welcome to the Intelligent World's new series of live broadcasts. We will discuss the world's most amazing innovations. And if your company has an innovation to share, or maybe if you know a company that has a great innovation, just contact me or direct message me or put it in the chat. So say hi in the chat. I'm really looking forward to chatting with you. Let me know where you're from. So which city, which country are you from? I'm now from the Netherlands, and we have a broadcast on over 6 channels right now. And we kick off with an amazing innovation video. After we have showed this, we will discuss it in more detail. And I would like to especially thank MIT CSAIL, who has shared this innovation. Now, let's start and let's watch the video. What an amazing innovation. These innovations, they are called Pneumatic, and let's make it a little. They are soft as robotic wearables. And previously, creating these type of pneumatic actuators was a manual design, and that's a lot of trial and error and a lot of testing to create this. And it's been very, very challenging to make this. But scientists, they have developed a new tool to design and to fabricate this soft pneumatic. Basically, you can use this software to create the parameters design of your own pneumatic actuator. And you can see what it looks like digitally and three-dimensionally on your screen. It's like making a digital simulation of the design to how it's going to work. Is a great way to produce, test, and trial and error. When you're finished making your design, a machine that uses digital machine nutting, it's your design, and simply fix it to kind of standard off-the-shelf type of rubber silicon tube. That then it's ready. Now, we're gonna check this out. So the knitted actuator, conductive yarn, and yarn digital machine knitting device is integrated with yarn that contains metal fibers. And these metal fibers woven to and fiber-based sensors can measure biopotential, but it can also sense strain, and it can detect touch, which are great capability. So just like in the video, when the fabrication robotic gripper, it's pressure to how much force applied the object, and then determine if it's successful or if it's not gripping at all. And because of this new design, new fabrication tool, people can start testing and building their own designs and uses this for pneumatic. And like in this example, they are used to sense touch and to conform touch the other object. Now, get them to move. Like you see, let's say, example video. It simply uses compressed air, and I believe that's pretty amazing. So it can be fitting to them their ability to lift objects for, or move their limbs. Great capabilities. And you can also see the other example too, where people are getting really creative, even fixing the actuators, act robots, leg for example, and making that the robot move around on the floor. So these pneumatic actuators, they can have a variety of applications, like assistive wearables, robotics, but also rehabilitative type of technologies and interactive devices. Now, once again, if your company has an innovation to share, and it doesn't have to be like this one, any type of innovation, or you know a company that has a similar type of innovation, just let me know and we should present it. Let me know via DM, or you can chat me, or any type of social channel you can contact me and let me know. Now let me ask you a question. So if you've seen this, what do you think of this soft assistive robotic wearables? Are they useful? What type of application do you think they can be used for? Leave a comment in the chat and we start the discussion after I explain a little bit more. Now, let's take a little bit more deeper look and talk about what's behind. Behind is data and AI. So data is collected as input for the pressure sensing capabilities. And this data is interpreted in real time. You have to, because otherwise you cannot react to the gripping. And this is in the field of smart textiles, where textiles are being used to measure and to analyze all kinds of different activities. So just to give an example, digital machine knitting in the field of smart textiles. They can be used for sensing and for actuation applications, especially for this assistive technology and this assistive robotic technology. So like knitting a shoe or a sock, for example, that can be fitted and conformed to a specific person. So measuring the resistance points for each pressure sensor data, combined with deep learning image classification, you can create a heat map that displays sensor data. And this activity, they can be classified by using a machine learning model that can be trained to detect posture or motion. If we look to the future, machine learning techniques can be further explored to enable all kinds of diverse cognitive robotic tasks, such as grasp object classification or human interaction classification or learning-based control, for example. Now, let's see if we have some answers. I have some questions. So one of the questions that we have in the chat, where can you use it for? And one of the examples they say as grippers, so people that missing some limbs. It's a great thing. I think it's a great application, and especially in healthcare, that's one of the applications that's I think supportive for people that are missing these type of limbs, and I think it really helps them out. So if you know other applications, feel free to share them in the chat. This is a short live broadcast. We're going to do a whole series of it. If there's more innovations to share, we will make it longer. So once again, share your innovation, share your company's innovation, or if you know a company that has an innovation, just share it with me. Thank you everyone for joining us to talk about this really unique type of technology, and be sure to continue the conversation with us in our chat. And thank you for watching, and we are looking forward to seeing you next time. This is The Intelligent World, and we see you next time. Bye-bye.